Hi guys, welcome back to my channel. Today we have another printer review, this time looking at the brand new JGAurora A5S. It's been just over 10 months. This is JGAurora's latest printer. Let's take a look at what they've updated in the A5 series. So JGAurora recently announced two new printers, the JGAurora A5S and the JGAurora A1. I received the A5S myself about 2 days ago, so this is a brief review showing you my first impressions only. Firstly, I need to acknowledge and thank JGAurora for sending me this printer free of charge for review. I don't have any commercial relationship with JGAurora, but I have been pretty closely involved with the JGAurora A5 community over the past year, so I feel that I'm fairly qualified to speak about what I've seen, such as the quality of their products and also what their customer service has been like. Before we get started, I will say that on the surface, the A5S appears very similar to the previous model, the JGAurora A5. However, it is actually quite a different printer inside, and I'm going to be doing a follow-up video later on showing the main differences between these two different printers. However, this review is from scratch. I'm not assuming you know anything about JGAurora, and hopefully this video will give you enough that even a newbie to 3D printing could decide whether or not this printer would make a good startup for your first printer. My printer came well packaged. It arrived in one large box, which on opening revealed the printer in two main parts. Inside the box we get a few accessories. We have a brief assembly guide. We have an SD card which has an installation video. We also get a USB cable, some advice from JGAurora that this is a unit that has been tested in the factory, so you may notice some minor signs of use. Came with a whole bunch of hex keys, a warranty card, a USB card reader, and a spare nozzle. The printer also came with a free spool of sample filament from eSun. This is a small 250 grams in a lovely orange colour. I've found the eSun filament to be good quality, so I have no problems with that. My printer arrived well packaged. It came in a big box, lots of high density foam, and I could see no signs of shipping damage. The printer comes separated into two main parts. There's the base chassis, which includes a moving bed and the LCD touchscreen, and then there's the XZ gantry, which is this part here, and this includes the extruder motor, the Bowden tube, and the print head. It also includes a mount, spool holder mount on the side for holding your filament during printing. Assembly is fairly straightforward. There's a bunch of connectors to plug in on the side. There's two screws on each of the sides, as well as four large screws on the bottom, and once you've done that, the printer's ready to use. Compared to previous models, JGAurora has definitely stepped up with the packaging. There were no signs of any damage on my printer at all. One thing to be aware of, during assembly there's a bit of a trap. On the base of the printer there's cables that run underneath, and you need to make sure that when you're assembling your printer that you don't crush the cables between the gantry and the bed. You need to make sure that those cables are out of the way. Lastly, the last thing to do is to mount the spool holder on the side of the printer, and then you're ready to start printing. The first thing to do is to load up filament. Loading filament is fairly straightforward to do. You simply press the extruder release button, located on the motor here. This will disengage the extruder gear. That allows you to feed up filament into the filament runout sensor, in past the gear and into the Bowden tube. Once you've got it in the Bowden tube, then you can go back to the front LCD screen, you can heat up the nozzle, and then you can load the filament the rest of the way into the printing head. The next thing to do is to make sure that your bed is leveled. What this involves is moving the bed and nozzle around to different points in the bed. And then you need to check that the gap between the nozzle and the bed is correctly set. What you want, ideally, is one single sheet of paper, and the kind of tension you can adjust is done through these little screws on each of the corners of the bed. What you're looking for is the nozzle to be creating some friction in the paper, but not preventing you from being able to drag the paper. It should feel like the nozzle is dragging in the paper, but you still should be able to move the paper around. If you've got that correctly set, go through each of the 4 corners twice. Once that's done, you should have a good level bed, and you can check the middle spot to make sure that's level as well. What you need to make sure you do is you need to make sure you perform the bed leveling with the bed hot, as the bed will warp slightly as it heats and cools. This bed leveling process on the A5S is entirely manual. There is an assistant on the front LCD screen. That assistant will move the head around to 4 corners and to the center conveniently for you. However, the process of actually leveling a bed is entirely manual. This is a little bit disappointing, as some of the printers coming out now are starting to come out with automatic bed leveling sensors, and I think this is a trend we'll see more of in 2019. Once you've got your bed leveled, then you're ready to print. With the A5S you have 2 printing options. You can print via SD card using the USB SD card reader included. There is also a USB port on the side of the printer. This allows you to connect the printer up to Prontoface, to a Raspberry Pi running Octoprint, and it gives you some more flexibility if you want to print and control the printer more remotely. With most printers, one of the challenges is getting materials to stick to the bed during printing and then removing them after printing is finished. This printer comes with a glass bed with a ceramic glass frick coating. JGAurora calls this their diamond bed coating. This coating is designed to stick well when the bed is hot, and then once the bed cools down after printing, the part should come away with very little effort. Most people who have used this bed material actually really like it, and a number of other 3D printer manufacturers have started to use it as well. There are 5 really important things you need to make sure to get a really good bed adhesion each time. If you do those, you'll have a great experience. Firstly, and most importantly, it's really important to make sure you keep the surface clean. Even the oil in your finger, if you touch the surface, you'll leave behind fingerprints, and they will significantly reduce the adhesion of the bed to your prints, and they may fail and peel off halfway through. What you need to do is, after every print, you need to clean the surface, or before as well, you need to clean the surface with isopropyl alcohol to make sure you have a fingerprint-free surface. Secondly, you need to do the bed leveling like I mentioned. You need a precisely leveled bed to make sure you get consistent first layer heights across the surface. Third, you need to make sure your bed is preheated. 67 degrees Celsius works well for PLA, or 105 degrees Celsius for ABS. 105 degrees Celsius is the maximum this printer will let you set. Fourth, you need to make sure you print your first layer really slowly. I recommend 12 millimeters per second. I find that works well for me. Any faster and you may not get the print sticking to the bed on the first time. This may seem very slow, but this is just for the first layer. You can increase the speed however you'd like to after the first layer. Fifth, you need to make sure you turn your cooling fan off for the first layer. This is normally off by default, but just make sure in your slicer settings that you have your print fan turned off for that first layer. If you follow those 5 tips, you should have a great experience with this bed coating. I find it works really well. For printing your own files, JGAurora includes Cura on the SD card, along with a printing profile for the A5S. I'm working on getting a profile for the A5S actually added to Cura. I've submitted a profile to Cura development team on GitHub, and we'll wait and see if they accept that or not. Printing with the A5S is fairly easy. The main thing to be aware of with your settings is that you need to make sure you have retractions turned on. This long Bowden tube, the extruder motor is back here, and the extruder head is down here, and in between you have this long length of filament. Filament is very slightly compressible, so this means that actually there's a pressure within this tube, and this means that when you stop printing with the motor, there's still a bit of spring pressure left in the filament that can cause some oozing after the motor stops moving. So having retraction means it actually pulls back, releases that tension, and that should help to reduce your oozing. If you're getting oozing, try increasing your retraction length and your retraction speeds. Unfortunately for me, my printer did not work out of the box. As soon as I tried to heat up the bed on the printer, I got an error that the bed sensor was faulty. I disassembled the printer back into the 2 halves and then opened up the main chassis, and I found that one of the cables going from the motherboard to the temperature sensor on the bed was actually broken. This is really disappointing. This was a fault that definitely should have been picked up in quality control before the printer was shipped out. So I cut out the broken section of the cable and replaced it, and now the printer works perfectly. However, not everyone is able to do repairs or solder cables, so if you have issues, you can always contact the JGAurora support team. They are very helpful, and they would have sent out a new cable free of charge with no hassles. The only downside is waiting 2 or 3 weeks for the part to arrive and then still having to install the part yourself. If you get a new printer and you find it's faulty, it's worth buying from a supplier who has a good return policy, so if there is a fault, you can just send it back and have them send you a new unit. This brings me to my next point. This printer is not very easy to service or maintain. There is no documentation provided about how to open up this printer. When you try to open up the printer, especially the main chassis, there's a lot of cable ties in the way that you have to actually cut, and then those cable ties need to be replaced when you close up the unit. It really isn't very easy or convenient to perform even basic maintenance. Things like lubricating the rails that the bed runs on, that requires opening up the entire chassis and going through that process. And I had to cut around 8 to 10 cable ties in order to do the repairs I had to do for the bed cable. I really wish this printer was easier to service and maintain. Aside from the broken bed cable, there were no other faults with my printer. Now the A5S is a large printer with some large moving parts. For good quality prints to be possible, it's important that the frame is stiff and rigid, and this is the case on the A5S. The main chassis is very stiff, the bed arms are definitely improved, the main gantry system is quite stiff, with only minor deflection when pushing backwards and forwards. All the rails and everything are adequately sized. I'm overall satisfied with the build quality and the motion system on the A5S. However, the bearings on the printer are another story. The bearings they've used on the A5S are really low quality. The bearings on the bed, moving the bed back and forward, was very grindy and very stuttery and very rough, almost like running a car on pebbles. The bearings in the X-axis were not much better either. Since I had to replace the bed cable and open up the printer anyway, I actually went all the way to disassemble the bearings on the bed and take a look at them more closely. The factory bearings have quite a high preload, which means they fit quite well on the rails that the printer runs on. However, the quality of the bearings is very low, so those bearings run very roughly on those rails, with lots of stuttering. This extra friction and stuttering means that the printer has more vibrations going on, which translates into reduced print quality, as well as putting a higher load on the motors to move things around. I managed to find some spare bearings that fit perfectly in my component drawers. These were not expensive parts. These were just random bearings I had from eBay, and even generic bearings with no brand names, they still performed amazingly better than the stock bearings. I'll show you a demo here comparing the old bearings and the new bearings. So this is a demonstration of 2 different bearings on the JGAurora A5S. This bearing is a stock bearing as came with my unit. This bearing is a generic unit, dead cheap, that I had in my box of my wall of parts. There's no wobble, it's got a good preload, runs smoothly, reasonably quiet. This is the JGAurora bearing. I don't know if you can hear this. Absolutely horrible. So if you're wondering why your printer's noisy, it's because they've used terrible quality bearings. This is just not good enough. I mean, I know the printer is cheap. By cheap, I mean under $1,000. But this is just garbage. That's a bearing. This is just, this getting stuck can cause layer shifting. It can cause, the vibrations from this will travel throughout the printer's frame, affecting your layer quality. It's just not good enough. As you can see, the difference in those bearings is quite substantial. I don't understand why they've gone with such poor quality bearings. I'm hopeful that in the future JGAurora will purchase better quality bearings, because as it stands, these ones are simply not good enough. The electronics on the A5S are actually quite good. Rather than using a third-party product, for the motherboard on the A5S, JGAurora have actually engineered their own custom motherboard, and along with this, their own custom proprietary firmware as well. The motherboard is powered by a more powerful 32-bit ARM processor, and the stepper drivers they're using are Allegro A5984 stepper drivers. These drivers run quite cool, And they're also running them at a much higher micro-stepping rate, which means the motors are both more quiet and also run more smoothly. And this is a good thing for print quality. However, these stepper drivers are soldered to the main motherboard. This means that if, say, a wire breaks and the stepper driver is damaged, you have to replace the entire motherboard. Previously, you could just replace one stepper driver, and that would be a much more cost-effective replacement. The software platform that JGAurora have created supports some more smart features too. They've got support for filament run-up detection, a feature I've tested and it works well, and in theory it supports a power outage detection. However, the firmware that I've been testing with this weekend doesn't seem to be functioning correctly with that feature. Okay, this is a quick test of the power resume feature on the JGAurora A5S. I've got printing and benchy here, and yes, I forgot to turn support off. I'm going to take out the power and we're going to see if this feature works. Okay, the power's off. You probably heard those wonderful high quality X-axis bearings. Let's plug it back in and see how we go. So on the LCD screen we get a prompt asking us if we want to resume the print. All looks good here. Let's go yes on that. The bed and the nozzle start reheating up to temperature. The nozzle homes itself so it gets an accurate reference point. It also purges a bit before it continues the print. Now unfortunately, in this case, it looks like we're suffering a layer shift. The X-axis has not correctly resumed the correct location. I'm not sure why this is. I've done several tests and it doesn't seem to happen with all parts. I did a test part with a cube and it didn't suffer from this effect, but I did several tests with benchies and they've always suffered from this layer shift effect when using the power resume feature. So it does work. I do think there is still some firmware or some slicer settings that I haven't got quite right, or it could be a firmware bug of some kind, but at this stage the hardware side of the resume works, but the software doesn't make it a useful feature at this point. There is still hope though that they could fix the firmware, or they might provide some guidance on what settings are required to make this work accurately, because like I said, some of my prints did work correctly with the power resume feature. It's only some of my prints that have suffered from a layer shift, and I'll bring the camera closer so you can see this. So you might notice here there's a line there where the layer has actually shifted when the power was resumed. And the same thing happened on this benchy as well. You can see lower down there's a rather large layer shift at the bottom there. Otherwise the print quality is pretty good. I'm very happy with it. There's none of that salmon skinning because they've got the better quality drivers in this. So overall it's actually a really good quality print. And this is the cube, and I did twice actually. I did a power resume and worked flawlessly both times. So I'm not really sure what the difference was between this print and that print. The settings were actually identical, but it seems to be in intermittent success with the power resume feature. And the layer shifting only seems to be on the X-axis, so I'm not sure what's going on there. If there's something specific to the X-axis or not, I'm not sure, but I've tested the filament out sensor. That one worked perfectly every time. It seems to be just the power resume feature that has this issue. So, like I said, they may fix it, but I thought I'd make sure I show you clearly my experience with this feature. Finally, it's important to note that this is the proprietary firmware, and you get what you get. It's up to JGAurora whether or not they decide to continue to add features to this platform or not. Being a new platform, I would imagine it's likely. However, there is no guarantee around that, and there aren't any other options for firmware on the A5S. Now the wiring on the A5S is okay. They've used good quality wiring and most of it's neat and tidy with lots of cable ties. However, there are a few points where there is a definite lack of strain relief. This corrugated tube is intended to help the cables avoid being kinked, but there are still a few pain points where as moving parts move around, there is a significant amount of flexing. I would expect after about 500 to 1000 hours of use, you might start to notice some wires start to fail. And I've already talked about how hard this machine is to open up and service. For this reason, I don't think this machine is suitable for industrial or commercial use. I think that it's perfectly fine for hobby grade use, especially if you're happy to tinker and replace wires as they wear out over time, but it's just not in the same class as an industrial or professional machine. Finally, the power supply that powers the A5S is a 24 volt, 300 watt power supply. This is definitely adequate. It does heat up the bed sufficiently, but it is definitely not as powerful as some other printers. And what this means is that the bed is quite slow to heat up, as you'll see in my video here. So in conclusion, is this a printer that I'd recommend for a beginner as their first printer? Well, maybe, but I think it depends on what your goals are. The large build volume is fantastic if you want to print large cosplay pieces or you have really large projects in mind like a rocket ship or something like that. If you just want a machine that you can put files into and get out 3D objects, then the A5S might be a great place to start. With only 8 screws, you can be up and running, having plastic printing from the SD card sample files within 30 minutes quite easily. However, the instruction manual that's included with the printer is quite brief and quite basic, so you're probably going to be more dependent on the community to answer your questions and to learn more about how to use the printer. It would have also been nice to have seen an automatic bed leveling probe. That would have made it much more convenient to get started with this printer, rather than having to go through the manual bed leveling process. However, if you're someone like me who likes to tinker and play a bit more, then you might find the proprietary firmware to be a little bit restrictive. There are still lots of other choices out there, but you may not want to consider the A5S. You could look at perhaps the JGAurora A5. That printer has a fantastic community, a very similar design, and there is definitely plenty of firmware customization out there for that printer. If you do decide to buy the A5S, then I'd recommend in particular buying from a store that accepts PayPal or a store with a really good return policy. These printers come in large boxes and bad things can happen during shipping, so it's worth paying extra for shipping insurance if it's offered, just for your peace of mind. Lastly, I've put links where to buy the printer below in the description. If you use those links, that supports my channel, so thank you for that. I've also put links to a number of other useful websites down there, including the JGAurora Facebook group, the wiki, and the forum. Hopefully, with those information sources, you'll be able to answer most of your questions. Thank you for watching my video, and happy printing! Okay, so the review's over, but there's one more thing I forgot to do with this printer. Here we go. Yeah, that was worth it. See you guys.